Okay, so that was volts. No, it wasn't amps and it wasn't volts. It was ohms. Maybe I should start talking that. It was Lululemons. All right, and the three main rules were turn it on, zero it out, and never with power on. Okay, I think those are my good three rules right there. Now let's do volts. 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 Okay, so here's my dial over here. So we had ohms was R times 1, R times 100, R times, and R stood for what? Resistance. Okay, so on this one, V is going to be volts. V equals volts. And notice we have, we're going to look at the big letters here. I need red, otherwise you won't be able to see it. Red or yellow, yellow. Okay, the big letters, 2.5. It's right here next to the white arrow. And we have 10 and 50, 250, and 500. Now below it we have 1 volt. And below this we have, what's that funny little thing there in there? Micro. It's muse actually, so microamps. And this one is for 10,000 volts. And notice how it's in small letters. Okay, what that means is you have to reconfigure the wires to make it go to that. So for example, if I want to measure 1 volt, I'm just going to tell you this so you'll kind of, now we be Monex then, bad name. If I want to measure, this one doesn't even have it. This one's a little different. 1 volt, what I'm going to do is put it on the 1 volt setting and then look around here for wherever it says 1 volt. And I'll pull that up and go right there, 1 volt. Okay, so that reconfigures it. But for the most part, and that's okay. If you forget, you go, well, I don't remember how to reconfigure it. In this class, I will tell you. In fact, I need to do it in the other class too. I don't mind telling you, so just know that. Yeah.
I had a clarifying question about the ohms real quick.
Yeah.
You say never measure with the battery attached?
Yep.
Attached to the...
Your project.
The project.
Yeah, like if I'm trying to measure the I have a light bulb and the light bulb's on. I'm like, hey, I wonder what the resistance of the light bulb is. And the light bulb's on and I try to measure resistance. Don't do that. Yeah.
One of the rules we always have is before we go to the ohms scale on any wiring in the aircraft, we double check voltage first to make sure that wire is not hot accidentally.
Okay, there you go. Just make sure it's not.
Spike the gauge.
Of course, in this class, you can just look at your battery and disconnect it. So it's a visual. All right, but we're going to be working with the 2.5, 10, 50, 250, and 500. So
Positive lead is the only one that moves the
in that case, yes. On the 10 amps, it goes something else. So it depends. Usually, it's only the positive. All right, so we're reading volts. Oops, I cannot use black here. Volts. And my first scale was, I had 2 point, did I have one? I had 2.5. This one's a little different, but I think it's, okay, 2.5. I've got the 10, 25, 25, 50, and then 250, 50, and then 250. Let me see how, was this one different? 50, and then 250, and then 500. I had 500. Well, you're not going to be using 500, 250 very often in this class, but we're going to know how to read it anyway. All right, so I have these scales. I'm going to start with this 10 right here. I'm going to skip the 2.5 for a minute. But we're going to read that right here where it says DC. And what color is DC in?
Black.
Black. And what color is this right here?
Red.
Okay, that says AC. You guys can probably see that, but if you're... Oh. That right there is where so you know what I did. That it's where the picture is if you haven't watched the YouTube videos, so that's covering stuff. So, huh? Okay, I'm reading right here. Right there, AC, that's in red. So don't read down. This right here, it says 8 and there's a line. Don't read that. You go up. We're reading DC. DC is direct current. Direct current is what you get from a battery. So in AC, that literally stands for alternating current. And what that means is the voltage and the current, they get higher and higher and higher, and then they get lower and lower and lower, and it goes to 0, and it goes backwards the other way. So the current's actually going back and forth, up and down, back and forth. DC is a battery, and it just means that it's there. I got a battery, and it's a car battery, it's an aircraft battery, it's 12 volts. You can put out 12 volts. If you grab it, you're just going to get 12 volts straight. until the battery wears down, and it goes 12, 11, 10, 9, all right? So until it dies out, it stays constant voltage. But as it dies, it gets less. That's a whole nother lecture. All right. So that's why we're going to be reading with your battery up here. So battery. So if I've got on the 10 scale, I have to choose. Do I want to read the 10, the 50, or the 250 scale?
10.
That was easy, wasn't it? So if the setting is here, the dial is dial, I should have left room, then I want to read the 10. Oh, so this will be scale. Which scale am I going to read? I'm going to read the 10 scale. How hard was that? And that means that if the needle is right here, how many volts do I have? Okay, I'm going to come down here to the 10. And now notice it's backwards. This used to be 0. Now 0 is over here. Something else I want to point out. This right here, that is the maximum it can read. Whatever this is, it's the maximum. So what is the maximum voltage I can read on the 50 scale? It's the maximum voltage I can read on 250. Right, you think that would be something? Okay, so what's going to happen is I'm going to say, hey, measure this 12-volt battery. And you'll go, well, I guess I'll start on 10. What's the maximum voltage I can read on 10 volts? 10. Okay. Notice that we're going to read this bottom scale, and it starts out at 0 and goes as high as 10. Okay, so notice it's backwards. So this is 6. So what must this be right here? Half. That happens to be 7. What is this? All right, that's 0.2, 2, 4, 6, 8. So that's 7.2. This is 7.4, 7.6, 7.8, and that is 8. So it's just a direct reading, but again, you have to count what things are. What if the scale, the needle's right there? I hear 5.6. Okay, that's 4. Here's a big line, and that's 6. So halfway in between must be 5, 5.2, 5.4, 5.6. That'd be 5.6 what? Volts. 5.6 volts. This is not hard, is it?
I'm sorry. Where does it begin?
Where does what begin?
The
scale?
From 0? Yes.
Here's 0 right here. And we're going up.
Here.
So this is 0, and this is 1.
Okay.
So I'm reading right here. 0, 2, 4, 6, and I'm reading upwards. Never the red,
Okay.
unless I'm on AC. So that's 1. So what if the scale is right here?
10.4.
I say it's like
0.4.
Okay, 0.4. Now, if, and I'm going to tell you right now, if I said measure that, and the scale's right here, and he says 0.4, the first thing I'm going to say to you is,
what?
why are you not using 2.5? And I know what your answer is in your head, because 2.5 is the hardest scale to read. That's why I'm going after it later. But you need to be using the appropriate scale. Otherwise, I'm just going to make fun of you. You're like, well, it's easier just to put it here, so I have to go back and forth. And my response is going to be, well, then just set it for 500. And then you'll think about that and go, yeah, okay. So, oops, I shouldn't erase that. Oh, well. So we did the 10. Yeah.
Like, is 5 volts like a lot? Or is it like
It's a really, really low. So what comes out of the wall is 110 volts. Car battery is 12 volts. Some aircraft go as high as 24. Your little the things that go in smoke detectors, that's 9 volts. So it's not much at all.
Oh.
Your little battery is 6.
Oh, the battery.
And now that's nominal voltage. That means that it could be more, it could be less.
Yeah, when I test car batteries at work, they normally read 12 point something.
Yeah, they're 12.6.
Yeah, close about.
Okay, so the next scale we had was 25. So I'm putting 20 next setting. So at 25, what scale am I going to use? The middle one? Okay. All right, I'm going to go back here. I wish I would have erased it all because that was. But I had 2.5. I had 10. I had 25. I had 50. 25? Yeah, 25. 2.5, 10, 25, 50, 250, and 500. I want you to notice right here that there's a pattern. What does this one, and this one all have in common?
Five.
What do they all have in common?
Which is what a decimal point's at.
Decimal point, but it's all got a thing of 25. Which scale do you think I should use? The 10, the 50, or the 250? Which one matches? You're right. I'm always going to read those on that one. All right. Let's see. Yellow. What does this one and this one have in common?
50.
They're all going to be red here. And purple. What does 10 is just 10. So there you go. It'd also be 1 too in a lot of cases. Okay, so if I'm going to work on the we'll say 250. We'll just jump into something a little more difficult because if I've got we're going to do 25. We're going to do 25. So I'm on the 25 scale. I'm right here, 25. So I put it on the 25 and I've got it right here. What do I have? Now this is a little more difficult because what's the maximum voltage I can read on the 25 scale? 25. So and which one of these am I going to use? 250, 500, or 10? 250, 50 or 10, so I'm going to say. Okay, so if the scale is right here, what am I reading on the 25 scale? I'm reading 25, so I have to move the decimal place 1 over, and that's what I'm going to be reading. So you could just kind of pretend that there's a decimal place moved 1 over on all of those. Everybody follow so far? Okay. So if it's right here, this is not 150, it's 15. And this is not 200, it's 20. But now you got to figure out what each one of these count as. So 160, 170, 180, 192, 16, 17, 18, 19, 20. Did that work out? Nope. 15, 15 and a half, 16, 16 and a half, 17, 17 and a half, 18, 18 and a half, 19, 19 and a half, 20. Did that work out?
Yeah.
Okay, so each one of these is worth a half, 0.5. So what is it right here then?
16.5.
It's just 16. What is it right here? That's 16.5. What is it right here? Well, try it. 5, 5 and a half, 6, 6 and a half, 7, 7 and a half, 8, 8 and a half, 9, 9 and a half, 10. So that would be 7.5 what? Volts. Okay, I'm going to warn you about something, and this goes for this class, especially starting this week, and pretty much through the rest of the time you're going to know me. The last thing you ever want to do is sit there confused, dazed and confused, and say to yourself, you know what, I'm just going to get through this. I don't understand a thing he's talking about right now, but how bad could it get? It's just one little thing. Okay, everything with me adds on, adds on, adds on, adds on. So if you come in tomorrow and you're completely lost because you understood none of this, you won't understand the next day. And then it's just kind of all over with. So always make sure that you are brave enough. No, I will never make fun of somebody for not understanding. If it gets too bad, I may ask Kelly or Katie to explain it and move on. But don't be afraid. That's what we're here for. All right?
So, from 2.5, so like say 200, that would just be 2.0.
And whoever said there was no such thing as a stupid question was just wrong. So okay, sorry.
So the 2.5, so like say like for 200 volts being exact, that'd be just 2.0.
What? Right here?
Yeah.
If
so
it was right here.
for the
If it's
2.5,
right here and we're on the 25 scale, how much is that?
will be 20. but
20.
For the 2.5 scale.
Okay, so you want to do 2.5 scale? Let's do that one. That's a good segue. I think now is a good time to do that. So now we're going to put on the 2.5 scale. So I'm going to write that here, 2.5. So I put it on the 2.5. What's the most voltage I can read on the 2.5 scale?
2.5.
2.5. And if it's right here, how many volts is it? 2. I'm just going to move everything over 2 decimal places. All right, what is it right here?
1.65.
1.65.
Is that right? Half.
1, 1.5, 1.6, 1.65, 1.7, 1.75, 1.8, 1.85, 1.9, 1.95.
I forgot.
I missed one.
Skip one.
I skipped one. The other one's what worked out.
I was right?
He was right.
Awesome.
All right, so
No, but it's one.
this is right here. How much is this here? This is 1.75. So is it, so halfway between is 1.75. This is, so is it 1.65?
Oh, yeah, that's right, that's right.
Okay,
You confused me.
and this is, so it's adding 0.05 each time, because right here
Oh.
is
yeah.
1.55. This one right here is 1.60. This one is 1.65. So you're adding 0.05.
Because we moved the decimal place.
Yep,
over,
that's
right?
what makes it a hard one. Okay. But if I ask you to measure something, let's say your 6-volt battery, which one of these scales would you choose?
2.5.
Gotta choose 10.
Got you.
Trick
Yeah,
question. Why can't you choose 2.5? Because the maximum you can read on 2.5 is,
Oh, yes.
and your 6-volt battery. So, all right, I could do this probably, over and over. But it's just practice that you have to do and you have to understand, and pick which scale. But I now know and I can trust that you know that the 25 is going to go with the 250. 25 is going to go to 250, and 250 is going to go to 250. And 250, you're just going to redirect. 25, you're going to move the decimal place over 1, and 2.5, move the decimal place over 2, right?
Mm-hmm.
Okay. If I want to read the 500, if I put on the 500, which scale am I going to read here?
50.
Going to read the 50, and what do? I heard it.
You're going to move it over.
Just going to add a 0.
Yeah.
So everything adds a 0.
2 plays.
So if I have it right here, how many volts do I have?
Where at? 2.
Right here.
2. This, 2. No,
250 volts, right in the middle.
Okay.
So how could we do that? What if it was right here?
Oh,
Figure out how many that is. Well, we can try it by tens. We just go back to zeros. So 20, 21, 22, 23, 24, 25, 26, 25, 26, 27, 28, 29, 30. Hey, it goes by ones.
Yeah.
So 210, 220, 230, 240, 250, 260, 270, 280, 290, 300. So right here would be how much?
220.
Okay, 220 volts. All right. You guys see it?
Yeah.
Okay. All right, so that's volts. Rules with volts. Let me see. What kind of rules can I tell you? When you have it on the voltage scale, number one, you don't need to zero it out, although I think it's hilarious, and I'm sorry, but you're here for my amusement too, is I will say, oh, did you zero it out? And like, oh, I'm sorry. Okay, it doesn't zero out because you do not use the internal batteries on volts. You use the battery from the circuit that you're working on. Okay? Voltage is done in parallel. All right. And this is going to be very important. A voltmeter has very high resistance. I'll just put the Lululemons there. And this is what a circuit looks like. This is the symbol for a battery. Technically, this is a multi-cell battery right there. This up here, this long, that's the positive. This down here, that's the negative. And if I draw a circuit, this is going to be a series circuit. That's a resistor. If they're supposed to look nicer than that. All right, so I have one resistor. I'm going to put in 2. 2 resistors. Okay, so that's a circuit. It's a complete circuit. And it's a complete circuit because, and I'll cover this later, but it's got a couple of things. One, it's got a voltage source. 2, it's got a load. That's my resistor. And it's 3, it has conductors. These are wires. And 4, it's connected. So I have current is now flowing through this through my resistor, up, around, and over. Okay? And voltage measures what? Do you remember the words that I use? Pressure, or better is difference of potential. It means that it's reading, so you have to read from one side to the other. Sort of a positive to negative, if you will. And because of that, voltage is always done in parallel. So series means one path, and parallel means two paths. So this is what a voltmeter symbol looks like. It's V with the circles. That's a voltmeter. So if I have a voltmeter, and I'll always do that, these are my wires that I add in here. I'm going to put the black one there and the positive one there. This means that it is in parallel. It has two paths for electricity. So electricity, which happens to be purple, it's a little known fact, comes out of the battery and it's going to flow and it's going to get to right here and go, electricity, it's going to go, well, some of the little electricity guys, the electrons, they can go this way and some of them go this way. There's two paths. It's split. It's parallel. All right? And a voltmeter has very high or very low resistance. Very high. So that means that most of the, I'll just use bad words for now, most of the, well, I'll say electrons, most of the electrons, that's a good thing to say, are not going to go through the voltmeter because, in a matter of speaking, they want to take the path of least resistance. All right, so most of them are going to go around and the circuit will remain relatively unaffected. Whatever was here before the voltmeters, pretty close to what is still there. So I hook up this voltmeter and it steals just a tiny bit of electrons and measures in here how much voltage, the difference of potential between here and here. Or if I want to measure what the voltage drop is across here, we're going to lose voltage because there's a load. So I come up here with my voltmeter and I put a red. I got red, so red's going to go this side because this is the positive side. And I'll put a black one here, and that's here. And that's okay. This is a good thing, right? I can measure the voltage there, and I can't really hurt the meter because it's very high resistance. But you kind of forget how to do this, and I did not want that at all. I want this here. And you think, you know what? I'm going to try this. I'm going to open up the circuit. I'm going to open it up. And now, of course, nothing is flowing because we have what's called an open right there. I'm going to put the voltmeter right here. Is that in series or is it in parallel? Now it's in series. Series is bad because a voltmeter has very, very high resistance. It's like putting in a very large resistor here, and it doesn't like it, and it changes the whole meaning of the circuit. Okay? So you don't want to do that. So very high resistance, and so we're going to say must be in series or parallel? Parallel. So it's always going to be in parallel. And to hook it up in parallel, it's really simple. I'm just going to do it here. I like here we go. This is how I like to do it. So this is my red lead, this is my black lead, and you can't see me on camera. Okay. So if I've got a circuit set up and I'll measure something, I can go like that, go like that, and I just touch it anywhere I want to. And I'm not going to really hurt anything. All right? If this is a 12-volt battery right here, what's this voltmeter going to read? It's going to read 12 volts. What scale do you think I'd want? 25. Good memory because you don't have it in front of you. All right. How many volts am I going to read right here? Don't know. I didn't give you that information. We're going to learn about that. It's not 12 because I have two of these right here. And we'll talk about Kirchhoff's law and everything else. But that was 12 right there. What if I hook a voltmeter up right here? I put a voltmeter here and right there. How many volts am I going to get? 0. There is no difference of potential. This is the same wire right here. So there's no difference of potential. I keep saying that over and over again. I wish I wouldn't do that sometimes. Because I keep saying it doesn't mean it's more true. There's just not a difference of potential. So if I put a resistor in here, now there's a difference of potential, and I'll get a reading depending on what the resistance is. If I were to open that up, now what would the voltmeter read? This is an advanced question. It's okay if you don't know that. You're going, how did he know that? It's okay. But does anybody know what the voltmeter would read there?
0.
It'd read 12.
How would that
Because I have total, it's like I said, because this is the red wire. Oops. this is the red wire, positive, and this is the black wire. And because it's open, there's no current flowing through anywhere. These resistors count for nothing, and only enough current to flow through this voltmeter is all I'm going to get, and it's going to say 12.
Because it's not a closed circuit.
Because it's not it's an open circuit. Sorry, that was a little advanced, but that's why you would get 12 volts there. But I connect this back up, boom, it goes to 0, because this is now all the red wire, more or less. And you can't just put it, there's nothing different. Whatever happens here is exactly the same as right there. And if this is the same as that, that says 0. Because remember, voltage is the difference of two things. What is the difference between this wire where I'm measuring and this wire I'm measuring, so to speak? So if I put it there on just the red wire, meter goes, well, the red wire right here at this point is exactly the same as that right there. So I'm going to tell you it's 0. So you have to remember that when you're measuring, it's the difference between one spot and another. So yes, there's still 12 volts in this circuit. It's just not between here and here.
Would the positive stop before the resistor, or would it go still, or would it start again after? Because on this diagram, to be exact.
Oh, where exactly is the positive? That's a very difficult question, because the positive, it's not really positive to here and then negative here. This is positive in respect to this,
Okay.
but this is positive in respect to that.
Okay.
It's wherever you're shooting from.
Makes sense.
You guys will get this. You know, it's just a little more experience. I just kind of went a little too deep right there. I'm sorry about that. Maybe I shouldn't have. But what I want to talk about is rules. So rule number 1, O is in parallel. Should I have the battery connected or disconnected? Got to have it connected. You're not going to get anything, or you get the wrong answer. So what else do we have there? So that's really voltmeters. That's one of the easier ones. All right, because you just have to pick the right scale and then use the scale. Not such a big deal. Okay, let's see here. Now we're going to do amps. Okay, amps is, and I saved the hardest for last. So amps. Well, first of all, let's talk about what we're looking for amps here. What color do I have? Black. We're going to go to red. Okay, so my amps. I've got 500 milliamps, 100 now they used a capital M, I don't know why. 10 milliamps, 1 milliamp. What about just amps? Well, right there you'll see it in little letters, 10 little letter amp. What does that mean? Got to reconfigure it. Well, there's glare on here, but this is the plus 10 amps, and this is the minus 10 amps. And so you would have to reconfigure it. Black would go to here, and red would go to there, and then you can read up to how many amps?
10.
Up to 10 amps. If you were to read the book, which many of you won't do because, I believe it'll tell you that the 10 amp circuit is not fused, which means if you mess up, what happens to the meter? It gets melty. That's an industry term. It gets melty. There is a fuse in here that is going to save your bacon. And I'm sorry, James. I know he doesn't love this. I will stand there and let you blow a fuse over and over and over again. He wishes that I would stop you. No, you're going to blow a fuse. I just kind of stand there and go, well, now your meter doesn't work. What happened? I blew a fuse. And then you got to do the walk of shame. And you got to go up to the toilet. We got to bring your meter. And you got to go to see James. James, I blew a fuse. And can you help me? And he's going to say, give you a little piece of paper. You want to tell the story?
Me?
You work at Napa?
Oh, yeah.
And he met a whole bunch of students because...
Everyone blows fuses.
And they go to Napa to get new fuses, and he works there. So you can maybe ask him if he wants to bring it.
That's how I met him.
Who? MJ?
Yeah, I was like, I recognize you. He's like, yeah, I came here for fuses for this class.
Okay, so let's just all be honest. MJ blew a fuse, and MJ's a great student. So if you blow a fuse, that mean you're a bad student? Yeah, it does. And I'm gonna make fun of you. No, it happens. What?
Why is it a capital M if it's a million?
I don't know.
Oh, it's just
Their typewriter was stuck on cap lock.
okay.
They're shouting it. It's milliamps. They're shouting it. All right. All right. So this is all. So we're pretty much going to be dealing in milli. And the reason why we're going to be dealing with milli is because really amps, that's a lot. You got to remember amps will kill you. But at the same time, you kind of need some voltage behind it too. So, for example, our Magnaflux machine in the other room, that new equipment I showed you, I can play with about 4,000 volts on that thing. And I can hang on to it at 4. In fact, one of the students did. He didn't let go. I've done it many times. You can hang on to that as 4,000 amps go through a part, and it does not hurt you because you, number one, have, it's volts, 4,000 volts. You have a lot of resistance, and so that protects you. Also, there's not many amps on that machine, so it's just not enough to. Anyway, so we're going to talk about this. So our scales are 1, 10, 100, and 500. Yes. So I've got. So I'll write this down for you guys later. Let me see. I think I put the actual.
Oh yeah, like this many.
Yes. Okay. So this is, and I'll tell you this later. So I'll just because we're there. Now your body has a lot of resistance, so it takes more than a few volts to cause current to flow. So you have to have quite a bit of voltage to cross the resistance barrier of your hands. So a calloused dry hand may have more than 100,000 ohms. Don't believe me? So I want to measure how many ohms that I have. So I'm going to go to 10,000. What's the first thing I got to do?
Turn it on.
Turn it on. What's the last thing I should do? Turn it off. I always forget. So, all right. I'm going to put that right there. And what's the next thing I have to do? Zero it out. Okay, so I'm going to touch the two leads together. Do like this, touch them together. And I got to zero it out. And then I'm going to take it, I'm going to hang on to it. And what do we got right there? I'll pull it up over here and I'll show you what I've got.
30.
We'll just say 30. Oops. So it is, where'd my pen go? There it is, pen. It's, well, we'll just say it's right about here on the 10,000. So, let me see. Oh, that's a little bit different now. Depends on where I go. Ooh, now I got right there. We'll call it 15. 15 on the 10,000. How many ohms do I have? 1, 5, 0, and 3 zeros. These come off, by the way, and so you can have little pokies on them, and so you can really get in there. You can just. Okay, now that's your dry calloused hand. So inside of your body, it's a little different. Just stick these in your mouth real quick. No fun.
And his hands all over.
Zeus. You could put one in your mouth and one in the. Never mind. All right. Okay. So, okay, dry calloused hand, about 100,000. I was pretty close to that. Internal body resistance is only about 300 ohms. So 1 milliamp. How many amps is that? How many amps? 0.001 amps. Tingling. It's like licking a 9-volt battery. Who here has licked a 9-volt battery to see if they work? That explains a lot to me. Okay. So that's about 0.001. Tingles a little bit. Okay, 0.005 amps, that's 5 milliamps, accepted as the maximum harmless current. 5 milliamps. 10 to 20 milliamps, you can have muscular contractions with an inability to let go. 100 to 300 milliamps may cause VFib, heart fibrillation, potentially fatal. 6 amps, sustained ventricular contractions followed by normal heart rhythm. I don't know about that. Temporary respiratory paralysis and possible burns. 6 amps and up. So but it takes a lot of voltage sometimes to get that 6 amps, and you'll see that with Ohm's law.
So amps relies on how many volts there are?
You have to have pressure to get it in you. If you don't have enough pressure, then it's not going to go. But if you get enough pressure, then it can do a lot.
So it's almost like sort of like blowing up a balloon. You know, putting air in it, if you don't have enough pressure, the balloon will inflate.
Okay, yeah. All right, so we were about to go to amps. Okay, so we have milliamps. So my scale is 1 milliamp, 10 milliamps, 100 milliamps, and 500 milliamps, if I got it right. I did get it right. 1, 10, 1. Okay, so for the 1, 10, and 100, which scale am I going to use? 10, 50, or 250? We're right back here. Because notice it just says DC. Doesn't say DC amps. Doesn't say DC volts. It says DC. So we're going to use the same scale. So you want to use the 250, 50, or 10? 10. Use the 10 scale because the 1, the 10, and the 100, they match the 10. When I measure 500, I'm going to use the 50. Okay, so that was pretty easy. What about the 250? Nope. All right, so if I've got, let me see, I'm going to have it right here, right through there. How many, and I'm going to put on the 1 milliamp scale, 1 milliamps. How many milliamps do I have? By the way, if I have it on the 1 milliamp scale, what's the maximum amount of amps I can measure? 1 milliamp. Okay, so what does it read right there?
548. 7.5.
Is it 8?
No.
It's right through the middle. So why is it not 8?
It's not 8.
Why is it not 8 milliamps? Or is it?
.8.
Well, it's 0.008.
What?
Because it's a 10 scale.
Okay, first of all, let's back up. What is the most I could be reading? 1. So it's got to be less than 1. Where's my 1? So right here, that is 1 milliamp. Oops, 1 milliamp. So how many is it right here? 0.8? But it's not 0.8 here. It's 0.8 here. You follow that? Don't read the red line. So it's not 0.8. Okay, so this is how much right here? 0.6. How much is this? 0.7. So how much is this right here? 0.72, 0.74, 0.76, 0.78. So it's, well, points. Oops, no, I can't see. So it's between 0.78 and 0.8. So right in between, how much is it? No. What's between 0.79? 0.79 what? Milliamps. That's one of the harder ones. All right, what if I have it right here and I have it on the 10 milliamp scale? Sorry. Got it on the 10 milliamp scale. What's the most I can read? I'm not hearing a lot of 10 what? Milliamps. Okay.
6 million.
Feel like I'm losing some of you guys.
I'll be 6.
Okay. If it's right here, how many milliamps is it? 10. How many is this? 6 milliamps. It's not hard. All right. What if it's right? We'll put it right here. Right there. Just making up stuff. On the 10 milliamp scale. The most is 10.
3.4.
Okay, so 10. How much is this? 8, 6, 5, 4, 3. So it's between 3 and 4. So 3.4 by 2. So 3, 2, 4, 6, 8, 10. Yes, it goes by twos. So that's how I do it. I just literally count that. So I go 3. So it's we're on what 10? 10. So we're going to redirect. So it's 3.2, 3.4. 3.4
3.1.
milliamps. All right, now we're just going to put it on the 100. So what's the most I can read? We'll just read it right here. Most I can read is 100, so that makes this 90, 80, 70, 60, 50, 40, 30. So how much is it right now? Just 34. How much was this one? 60. Okay, that's really all there is to that. Now what I'm going to do is I'm going to give you a quiz. I'm going to tell you right now how the quiz is going to look and what it's going to be. I'm going to give you a quiz, and it is going to have it's not today, not right now, so don't freak out. You can freak out later. It's really hard to draw straight lines on this thing, I don't even know. Okay, so I'm going to give you something that has a line that just goes through like that. And I'm going to say on the 1 ohm scale, what does it read? If it's on the, that's R times, sorry. Try that again.
Terrible line.
I erased my line.
Well, the line was terrible.
Well, it's really hard to do.
No, start from the bottom.
Jeez, listen to her. Start from that.
So that's in the
Do you want to try this? Everybody makes fun of me. I say, come on up and do that. And they're like, ooh,
There,
this is
see?
actually really hard.
There
Okay.
you go. You just needed some
Okay,
instruction.
so I'm going to say R times 1. What is it? If it's R times 100, what is it? R times 10,000, what is it? If it's on the volts, I'll say, what if it's on 2.5 volts? You see what I'm doing? 2.5. And I'll do all the volts. And I'll say, what if it's 10 milliamps? What if it's 100 milliamps? What if it's 500 milliamps? And you've got to tell me, for each one of these scales, what that's reading right there. I'm going to give you a quiz on that. Not today, probably tomorrow. We'll do it tomorrow? Maybe we'll do it Wednesday. We'll do it Wednesday.
This is in class.
Yep. So you're going to come in class Wednesday and I'll be, boom, it's a quiz. You got to do it. Okay? So, like I said, if you don't think it's going to matter, boom, it just mattered. So that's what. All right. Important rules. Important rules. All right. So for amps, let's go back to this. So I've got this here. Okay. So let me think. An ammeter. Amp meter has very low resistance. And I believe it's actually spelled A-M-M-M-E-T-E-R. I said amp meter, 2 words. It has very low resistance. All right. So always place in series. And this is why. So right here, I have an ammeter. It's a circle with an A inside. And I say, you know what? I am going to see how many amps my circuit has. And I do that. It has very, very low resistance. So what's going to happen with this battery is all of the electricity available is going to say, hey, guess what? There is a path with extremely low resistance right through there. And that is the same thing as just adding a wire like that. And it will get very hot for just a brief moment in time, and then it won't, because the fuse will blow out. That is in parallel or series that I just did that.
Parallel.
That is in parallel. So anytime you hook up an ammeter, now if you hook it up here, you might get lucky if there's enough resistance here and it may not blow. Probably will. So every time you do that, it takes all of the current and it bypasses whatever you were trying to measure. And so how many amps will you get?
All of them.
All of them. You'll get all of the amps through there, and it will blow your meter. So don't do that. Let me see.
I said the 10 amp ones sometimes are fused.
They're not fused. 10 amp is not fused, so it just gets... See, everything runs off what they call magic smoke. And if you let the magic smoke out of the circuit, then the component no longer works. So watch this. Every single time I want to put an ammeter in to measure the current flow, remember now I'm measuring flow. I don't want an alternate. I want to see how much water is running through a pipe. Do I create an alternate path and see? Now you got to look at the pipe. All right. So I have to look. I have to open up the pipe and look. So if I want to know how much current is flowing through here, I have to open it up, which means physically it may mean if you'll have wires and you got to disconnect the wire. You got to create an open spot. And you go, well, okay, now I got to put the ammeter in here so that all of the current flows in one and out the other. It actually goes in this way and out this way, but it's got to go through the meter. The meter now has to be part of the circuit. So ammeter, so rule number 1, rule number 2. All right, there. Always place in series. If you do not place it in series, you will blow the fuse, and we already know what happens there. So, by the way, just so you know, what would be the difference? Would these all read the same or different? They read exactly the same because the current that left here has to go through here, and it still has to go through here and through there and through here and through here and through there, and it's the same all the way through. So whatever, just like a pipe, whatever starts here in a closed circuit is going to come back out here. All right.
So,
Yeah.
So how is it that on the other slide that you had, where you said that it was 0,
Why is it 0? Because you're not measuring flow, you're measuring pressure. So imagine if you had a pipe. Let's try this. You've got a pipe. You familiar with water?
yeah,
Okay, so I've got a pipe. I got a pipe right here. All right, and I take and I break it off right here, and I put a pressure gauge. Okay. Hey, by the way, there's different type of pressure. There's PSI. What does that stand for? Pounds per square inch. It's how I read it. What does PSIG mean? PSIG means pressure. PSI gauge. It's on a gauge, because when we're actually reading pressure, like if I did something right here, I said, well, and I put a pressure gauge here, and I just read it, it's the difference between what is here and what is outside. And outside, what is our pressure we have right now? 14.7. We are actually living under 14.7 PSI. All right, so but you don't notice it. We call this 0. So if I'm actually just have a PSI gauge right here, it assumes that out here is 0, not 14.7, right? But if I have PSIG, it'll do absolute. So it can change absolute. Boy, I hope I said that one right. But then there's PSI. What is that one?
For every square.
That's just Pepsi, all right? So that's a soda. So you guys are really lost today, man. So I try to give you an easy one, and you're like, I don't know even what PSI is. So, okay.
per every square inch, huh?
All right, so going back to here, what would my pressure gauge read right here if I'm trying to read the difference between here and here? So let's just say I have 60 PSI in here, okay? And this says 60. Why? Because it's the difference between here and outside. Okay, see that? So it's kind of like going like this. So outside pressure comes in. Oh, it's 60 PSI. So, and that's what you get. You have a car, tire. You have your tire. Try that. You have a tire. And it's Flintstone tire. And you got the little valve stem. And how much pressure do you put in your tires?
35.
All right, you're going to put 35 PSI in your tires. Okay, that is the difference between what's out here and what's inside. Your gauge is telling you the difference between the two. Okay, so that's kind of what you're reading here. The difference between outside and inside. 60 PSI difference. Now, if you took a pressure gauge on your car and you routed it, you had 2 valve stems now. 2 valve stems. Boy, that's an ugly looking valve stems. And you imagine 2 valve stems on your car. Okay, you check one with your little regular tire gauge, and it says 35, and you come over here and you check this one with your little tire gauge, it says 35, but then you connect them together with a gauge in the middle. What's it going to read? It would read 0, because if this is 60 and this is 60, then that's going to say 0, because there's no difference. It doesn't make the needle move, literally. So this would say 0, because it's the same here as it is here. This pressure is going to come this way and exert a force on the needle. This is going to come through and exert a force on the needle. And guess what the needle's going to say? I don't know, it's just 0. Because we can look at it that way. The force is the same on both sides. But if I put a restriction in here, restriction, that's a better restriction. A restriction, and I got 60 psi coming over that way, and I've got less here, then I'm going to have more pressure this way, and just a little bit right here. So the needle's going to start moving. Ooh, if that's just 30 here, then it would say, well, I can see a difference, and I've got 30 psi between the two. Follow that?
Yeah.
Well, if you can follow that drawing, hats off to you, because I'm looking at that going, I don't know what just happened. So, and even this, what is this, a donut? You left the sprinkles off. There you go. So, okay.
Okay.
All right, I think that's all I have.